Hi there guys, so in this video we are going to look at parallel lines and perpendicular lines. So you should have your notes with you and you can fill this in as we get started. So parallel lines are lines that look like railroad tracks. They're heading in the same direction. They're at the same degrees on a particular coordinate plane. And so they are lines that will never intersect or cross each other. So algebraically though, in their equations, how do we know that they're parallel? They will have the exact same slope. So for example, if one has a slope of 1/2, the other will also have a slope of 1/2. When they are perpendicular and they cross and make a perfect 90-degree angle, that's perpendicular. Lines will intersect at 90 degrees. How do we know algebraically that they are perpendicular? The slopes are what we call opposite reciprocals. Our worksheet says negative reciprocals, but really it's opposites. So if one of them is positive, the opposite will be the negative. And we already know what a reciprocal is. We flip it over. So if one was 1/2, the other would be the reciprocal, 2/1, and it would be its opposite. This one's positive, so this would be negative. Whereas if we had negative 3/4 as one of the slopes, the reciprocal would be 4/3 and his opposite would be a positive. So we could call these opposite reciprocals. Okay, so mathematically, these would be the two slopes we'd be looking at that would be perpendicular. So hopefully you have that on your page now. If not, you're welcome to pause the video. So here would be some examples. We are kind of talked about 3/4, so his opposite would make it negative. His reciprocal would be 4/3. For 2, we know he has an invisible denominator of 1, so we reciprocal and make it the opposite, so negative 1/2. Here we would make the negative into a positive, and so we'd had 8/7. For the number 1, again, it's 1/1, which is still 1/1, but we make him negative, so negative 1. And the opposite of a zero slope, which looks like so, must be a vertical slope, which is, hopefully you guessed it, undefined. Okay, so there are some examples there to fill in with your notes of those negative or opposite, okay, I like to call them opposite reciprocals. So if they were negative, it becomes positive, but they were positive, they become negative. So one of the ways we can be asked whether or not lines are parallel, perpendicular, or neither is when we are given points. So we would need to find their slope. So the slope of line AB, we're going to do our y2 minus y1 over x2 minus x1. So we're going to get positive 3, change these, and get 3/4. Oops. Sorry about that. So if we calculate CD, 3 subtract 0, and 3 subtract negative 1. So we're going to get 3, and we're going to get 4. So we have the exact same slope, 3/4 and 3/4, and so this will be parallel. Now, you can write parallel with 2 diagonal lines is its symbol, just like no solution was this. Parallel is 2 slanted lines running in the same direction. All right, so let's look at this one for AB. Again, we're going to use our point formula for finding slope. 4 minus 2 over 5 subtract 0, 2/5. And then in line CD, 3 subtract 8 over 3 subtract 1. Be careful, this will be a negative 5, and this will be a positive 2. And so 2/5, and then we make it a reciprocal, 5/2, positive to negative. This is perpendicular. And that symbol looks like so, like upside down T. They are opposite reciprocals. All right, so go ahead and give a try to problems 3 and 4. Pause the video here and then resume when you're ready. All right, so for A, B, we have 6 subtract 8 over 2 subtract negative 1. We're going to get negative 2 over 3. For CD, we're going to have 3 subtract 2 over 3 subtract negative 1. Here we're going to have 1. Here we're going to have 4. Now, it did say that we could have neither, and so this is an example of neither. These are not the exact same, and they're not the reciprocal. So for this one, we are just answering that they are neither parallel or perpendicular. All right, let's go here for AB. 4 subtract 3 over negative 1 subtract 2. This is plus a negative, so we have negative 1/3. For CD, 6 subtract 3 over negative 4 subtract negative 5. So we have 3. This becomes positive, and so we have a positive 1, which is 3 over 1 is 3. That's a reciprocal. 3 over 1, 1 over 3. 1 is negative, 1 is positive. So we have a perpendicular line here. All right, when we talk about being given equations, I'm going to move on to that section next. If we already have our equation written in slope-intercept form, which we do here, y equals mx plus b, y equals mx plus b, we can just look at our slope. The slope is positive 7, the slope is positive 7. They're exactly the same. When they're exactly the same, they are parallel. That one's done. So these ones that I've blocked out right here, they've already put these in slope-intercept form. So we have positive 4/5 here. We have negative 5/4 here. These are opposite reciprocals. This is perpendicular lines. Same thing here. We have negative 1/3. I meant same as in they're both in slope-intercept form. And now we have that they're opposite, but they're not the reciprocal. This is neither. So don't rush. Make sure you're looking at these. So there's an example of each one. Exactly the same, parallel, opposite reciprocals, perpendicular, and in this case, it's neither. All right, in this case, I blocked out just question 12. You'll notice that they are not in slope-intercept form. So we need to first manipulate the equations into slope-intercept form. So we'll start here. So we're going to take our x plus 6y equals 30. We're going to get y by itself, so we need to move this term. So we're going to subtract x. Then we need to divide by 6, and when we do that on this side, it's the entire side of the equation. So we have y equals, so we have 30 divided by 6 is 5. Remember that there's an assumed number 1 here, so this is negative 1/6 x. And we can move that around so we can just see the proper form. And there we go. So let's compare that to the other equation. So the only thing that is preventing y from being by itself is that 3. So let's divide by 3 on both sides. 18 divided by 3 is 6x. 6 divided by 3 is 2. And this is in proper form. So now let's look at their slopes. So this slope, remember, it could be written as 6 over 1. And here we are as negative 1 over 6. So we have opposite reciprocals. So we have perpendicular lines. All right, let's take a look at the next one. So we're going to take both of these and put them in slope-intercept form. So let's start here. 3x minus y equals 2. We need to move this term, so he's positive, so we're going to subtract him. And we are left with negative in front of the y, so that's -1, so we need to divide by -1. And we'll be left with y equals 2 divided by -1 is -2. And -3 divided by -1 will be a +3. So let's just put this in that proper form, 3x minus 2. All right, let's do this one here. 12x minus 4y equals 4. Let's move that term. Divide by -4. Remember, it's this entire side. So y equals 4 divided by -4, -1. -12 divided by -4, +3. Let's write this in proper form. 3x minus 1. So we have a slope of 3 and a slope of 3. We have parallel lines in problem 14. All right, now I want to talk about question 16. They're very short equations like we talked about with vertical and horizontal. So if we were to draw that y equals 6, then y is 6 no matter what x is. So 1, 6, 2, 6, 3, 6, and we're getting a horizontal line. Now, if we then create x is -1, so we have x is -1, 0, -1, 2, -1, 3. No matter what, if we have these two scenarios, we are going to get a perfectly 0 and a perfectly undefined, and we will have a perpendicular set of lines. So if one of them has y equals something and the other has x equals something, we are going to have perpendicular lines. Okay, so there are some options here for you to practice. If you look at this one that says parallel, perpendicular, or neither, you are going to determine if they are parallel, perpendicular, or neither, and then you can shade in the boxes as follows with these colors or highlighters or whatever, or you can just write the answer. The first three are fantastic. They're in slope-intercept form, but notice all the others are not. You will need some scratch paper to work these out. As you can see, there's no space to work them out. So let's just talk about these three real quick. I notice 3 is the slope, 3 is the slope. These are parallel. I notice 2/5 and 2/5, one positive, one negative. However, they did not make it the reciprocal. This would be neither. And over here, we have -1/4, then +4/1. These are opposite reciprocals, and we have perpendicular. So the rest we would need to work out. You could use this as a practice page. I will let you decide. On this page, there's a little bit more workspace. You still might want to use your notebook, but the top section has you determining by the points, and the bottom section has you determining by the equation, but they are all requiring you pretty much, I mean, this one's in slope-intercept form, but most of them, you need to manipulate the equations. So try both.